Okay, you've made it. Look how far we've come. We've covered an absolutely massive chunk of the Scikit-learn library, and we're still going to finish it off. We're up to the last section, putting it all together. We've been through an end-to-end workflow. We've seen how to get the data ready. We've seen how to choose the right machine learning model for our problems. We've fitted it to the data. We've used it to make predictions. We've evaluated a trained model. We've improved a trained model. We've saved and loaded a trained model. Now, let's combine all of this. All of this. Could we do it? Could we do it? Now, let's make a little heading. 7.0. Putting it all together. First thing, to give yourself a little pat on the back, right? Because we've covered a lot. And so far, it seems to be all over the place. And which it is, but not to worry. This is how machine learning projects often start out. There's a whole bunch of different experiments and code all over the place. And then once you've found something which works, the refinement process begins. And now, what would this refinement process look like? Well, let's remember our good old car sales regression problem, aka predicting the sale prices of cars? We'll use that as an example. And to tidy things up, we're going to be using Scikit-learn's, let's have a look, Scikit-learn pipeline. To tidy things up, we're going to be using the pipeline class. Now, you can imagine pipeline as being a way to string together a number of different Scikit-learn processes in one hit. So similar to like writing a function, right? You're getting a couple of different steps and you're putting them together. Pipeline of transformers with a final estimator. So a transformer or a transform is aka transforming data, getting data ready. And then a final estimator. Estimator, remember in Scikit-learn terms, is a machine learning model. So as a refresh, this is our car sales data. There's 1,000 rows and there's some missing data here, right? So there's missing here, and what we're trying to do is use make, color, odometer, doors to predict the sale price of cars. Now again, this data is imperfect because could you do this? Could you figure this out given enough time? You'd probably realistically need a few more parameters, a few more details about the cars before you could figure out how much they'd sell for. So let's stop talking about it. Let's get hands-on with the code. To start off, we'll re-import the data. So go pd.read csv ... We've saved it in our data folder. Car sales extended. Oh no, our data folder is not up the chain. Oh well. Car sales there we go. Car sales extended data missing. That's what we want. And then we'll have a look. We'll have a quick peek at it. Wonderful. So this is just re-importing this CSV file that we have here. Come back. Now, what did we say? We said we want to use these columns, so these 4 columns, to predict the price column. We'll have a look at our data types. So we've got make, which is an object, that's a string there. Color, which is an object, that's a string there. Odometer, doors, and price, which are, we've kind of talked about doors being a category as well. So odometer is our numerical column. And do you remember what we have to do for our data? We have to make sure that it's all in numerical format before we can build a machine learning model on it. And there's another little roadblock that we have as well before we can build a machine learning model, and that's if we go is NA, so is null.sum, we've got null values in some of our, well, all of our columns. We've got 50 missing data points in each of our columns. So that's also a big no-no with machine learning models. We need to make sure that the data is numerical and that there's no missing values. If we refer back to our keynote, all data should be numerical. This is things to remember, right? And there should be no missing values. Okay? Let's check it out. So what we'll have to do is, if we want to put this all together, we've done this before. We've seen filling data, we've seen converting it, but this time we want to use a pipeline to do so. So the Scikit-learn's pipeline's main input is steps, which is a list that contains a tuple, which has step name and action to take. We're going to see this in a second, but we're just talking through it. And in our case, our steps are, what are our steps? Well, first we need to fill the missing data, and then convert the data to numbers, and then build a machine learning model on it. So let's do it. We'll go here, I want to do this one so it's all in one cell. Let's put our steps here of what we have to do. Steps we want to do. All in one cell. Can we do it all in one cell? Because before, to do this, it took a fair bit of work. But let's see. This is what we're doing. This is our refinement process using pipeline. So step 1 is fill missing data. And then step 2 is convert data to numbers. Wonderful. And then step 3 is build a model on the data. All right, cracks knuckles, gets fingers ready. Let's do it. And if it seems like I'm going through this pretty fast, let me tell you, there's nothing here that we haven't covered except for the pipeline. But what we've learned in the previous videos, you'll be able to deduce, as well as reading the documentation here, what exactly is going on. So import pandas as PD, because we want to do this all in one cell. And then from Scikit-learn.compose, remember the column transformer? And then from Scikit-learn, this is where we're going to import the pipeline class that we're going to take advantage of here. Import pipeline. And then from Scikit-learn.impute, we're going to import simple imputer. This is what we're going to use to impute our data, so fill the missing data. And then from Scikit-learn.preprocessing, import one hot encoder. This is what we're going to do to convert our data to numbers, or sorry, we're going to use to convert our data to number. So getting data ready. These are the imports we're going to use for that. Then the next one is modeling. So from Scikit-learn.ensemble, import our trusty random forest regressor, because we wanted to predict a number. And then from Scikit-learn.model selection, import. Have we got that right? Yep, that looks right. I've been known to be prone to typos. Train test split, and we want grid search CV, because we've seen grid search being used before, which is going to search for some optimal hyperparameters for our random forest regressor. Okay, now we're going to set up random seed. So we'll import numpy as np. We'll go np random seed 42. Wonderful. Now, for completeness, for doing it all in one cell, we're going to re-import the data. So import data, and we're going to drop the rows with missing labels. So data equals pd.csv. We're going to go to our data folder. This needs to be a string. I'm going to go car sales. Extended missing data, that's the one we're after, the 1,000 rows version. And then to drop the rows that have missing labels, we'll go data.dropNA subset. We'll set that equal to the price column because that's what we want to predict. And that's our label. And we're going to go in place equals true. Okay. So all we've done is we've just replicated this here. And now we've dropped the rows which contain missing price values. So aka missing labels. Now, what we're going to do here is we're going to start to define the different features of the data set and the different transformer pipelines that we want to take place on that data. So if we come back up here, what transformations do we need to make? We need to change our make and color into numbers. We need to fill the missing values of all the columns in here. And we need to change our doors, because it's also a category. We need to change it to a categorical value. So we're going to, actually no. Forget what I said about doors. Let's see what we're actually doing in the code. So define different features and transformer pipelines. So for our categorical features, doors is a special case because it's already numerical. Categorical features equals make and color. Now what we're going to do here is create a categorical transformer. So this just means modifying the data. And to do so, we're going to use a pipeline. This is the first time we're seeing pipeline. But the steps in the pipeline are going to be first, we're going to fill with missing values with an imputer. So this is where the pipeline inputs take steps to take, right, one after the other as a list of tuples. So let's see this happening. The name is imputer, and we're going to, remember, this is the action to take. So simple imputer strategy equals constant, and then the fill value is going to be missing. So you might be able to deduce what's happening there with this particular case. We're imputing the categorical features with the constant value of missing string. Now we're going to create one hot and go one hot encoder. And to handle the unknown, so columns that it hasn't seen before, we're going to tell it to ignore them. Wonderful. And then we'll make sure that we've all lined up these things. So we're going to need 2. We're missing something here. We need to check where our brackets are at. We're missing one here. There we go. See, half of this is figuring out where your missing brackets are. And then door feature. We're going to define our door feature equals doors. And so the same thing again. So we're going to create a door transformer. Door transformer equals pipeline. Again, we're using a pipeline because this will all make sense in a second, right? Why we're setting up pipelines. So to do this, we have to press imputer. Then we want to do the same thing again. Simple imputer. And the strategy is going to be constant. And the fill value for our doors is we're just going to fill it up with 4s because 4 is the majority number in the doors column. Then next, we want numeric features. So our numeric features is our odometer column. KM, wonderful. And then we're going to create a numeric transformer equals, the first thing we're going to do is pipeline, steps, equal, and then again we need to impute values here. So imputer, simple imputer, strategy equals mean. So this means it's going to fill the numerical columns, in our case the odometer, with the strategy mean. So it's going to take the mean value of the odometer column and fill all of the missing rows in odometer with the mean of the rest of the values. Whew, that was a lot. Now, still not done, that's all right. We're going to set up the pre-processing steps. So remember what we need to do. We need to fill missing data. So this is part of our pre-processing. These two are pre-processing our data, and this is modeling the data. So our pre-processing steps are going to be fill missing data and convert data to numbers. So we can do that. Fill missing values, then convert to numbers. So to create a preprocessor, we'll instantiate a preprocessor using column transformer, tab autocomplete, and we're going to pass it. Column transformer takes transformers equals, and now this is going to be a list of the transformations we want to do on our data. And in our case, we have one called cat, short for categorical. So we're going to pass it the categorical transformer, and we want those transformations that we've defined up here, the categorical transformer, to fill the value simple imputer with missing and to one hot encode, make and color. We want those to be performed on the categorical features. We'll press tab autocomplete, categorical features. Wonderful. Now we pass it another tuple. So now we want it to do same steps, but this time using the door transformer, which is going to fill the door column with the constant value of 4. So we can go door feature. Wonderful. And finally, we wanted to finish up using the num transformer, which is going to take our numeric transformer and perform the imputation on the numeric features. Beautiful. When there's only one feature, so features as a plural is probably not correct. And now that we've done our pre-processing, right? So our data is getting filled, the missing values are getting filled, and then it's getting converted to numbers using what we've done here. The next step is to create a pre-processing and modeling pipeline. We can do this, as you may be able to guess, because I've used the word pipeline. We need to create a pre-processing and modeling pipeline. So now essentially what we're doing is we're putting our pre-processing steps together with a modeling step. And because there's multiple steps, we'll use a pipeline to combine them. So model equals pipeline, and pass it steps, which is a list containing tuples, and this is the name. So this is a preprocessor step, and we're going to pass it preprocessor. So the first step in our pipeline here, our model pipeline, is to run through this. And then the next step, we'll put a little comma here, we need to create another tuple, which is going to be our model, is our random forest regressor. Wonderful. So now we've got our model pipeline set up, which will go through pre-processing. Once the pre-processing is done, it'll build a random forest classifier on it. We can get our data ready. So split data, x equals data dot drop. We're going to remove the price column because that's the one we want to predict. The axis is going to equal 1. Y is going to be data price. Then we're going to create x train, x test. As we always do, y train, y test equals train test split, x, y, test size, we'll use 0.2. And then we're going to fit and score the model. So model dot fit x train, y train. Now model dot score x test, y test. Where have we got it wrong? Handle unknown. We got a typo, of course we do. Handle unknown. There we go. Change that. Woo! We did it. We did the entire pipeline in one cell, taking advantage of the pipeline class. So let's step through what we did. We imported the classes to get our data ready. Pandas, column transformer, pipeline, simple imputer, one-hot encoder. We imported the classes to do our modeling, so random forest regressor, train test split, grid search CV. We set up a random seed so our results are reproducible. And then we define different features and transformer pipelines. So we define the categorical features here, the door feature, the numeric feature, and then for each of them we created a few steps for our pipeline to take to not only impute missing values, but to one-hot encode, so turn all of our data that wasn't numbers into numbers. And then we set up a pre-processing step. That took all of our pipelines here to take the steps that we wanted to take on the categorical features, on the door feature, and on the numerical feature. Then we created another pipeline to put all of these steps together to not only pre-process our data, and then model it. So then we split our data into X and Y, and then into train and test. And so when we call model.fit, it's going to call this variable here, which is going to run this pipeline, which inherently is going to call the preprocessor step, which is going to run this pipeline, which is inherently going to run all of these 3 steps. You might be thinking, Daniel, whoa, this has got a lot going on. But if you go back through what you've looked at here, you'll be able to see, you can step through it and go, okay, I'm starting to piece together what's happening. And now if you scroll right back up to where we originally did this, filling data with pandas, filling data with Scikit-learn, and then modeling it on our car sales problem, you'll see that we did it over a number of different cells. And now we're doing it. We're building a full-blown machine learning model in 55 lines of code, minus some comments, and we could probably tidy this up if we're being honest with ourselves. But now you're starting to see is that in the beginning, machine learning is very experimental. Throughout the whole thing, it's very experimental. And so what it takes at the start is just code everywhere, trying different things, seeing how they work, and then eventually you can bring it down to something like this. Put it all into one big cell in a pipeline, going through the steps that you've figured out along the way. Now, of course, we'd want to probably improve this, use hyperparameter tuning, and that's what we might look at in the next video, is how to use hyperparameter tuning with a pipeline. Slightly different to how we've seen it done with just a regular model. So take a little break, step back through what we've done here because it was a lot. Don't worry if you don't take it in entirely. Have a read through the pipeline class of Scikit-learn documentation and see if you can line up what we've done in the documentation to what we've done here. Otherwise, I'll see you in the next video. We'll see if we can improve this score.